Hey, welcome back. Let us now try to understand the bitwise AND operation. I have declared two integer variables, x initialized with 10 and y initialized with 7, and then performed the bitwise AND between x and y and assigned the result to z. So let's analyze this, how this bitwise AND works. I'll just draw the least significant 1 byte, that means 8 bits of each of these variables. So x is 10, so the least significant 8 bits of x will look like this in the memory, and all the other bits are going to be 0. Okay, so this is 1010, that's actually 10 for x, and we have 7 there in y, so y will look like this. There will be 111, and we are performing the bitwise AND operator between x and y. So that means each bit of x is going to be ANDed with corresponding bit of y. That means we'll start from here, from the least significant bits of each of these variables. So this 0 and 1, the result of AND is 0, and this 1 and 1 will be 1, and this 1 and 0 will be 0, this 0 and 1 is 0, and all the left bits are zeros because they are all zeros for each of these variables. So they are all zeros, all these rest of the bits are zeros. So Z is going to have this 32 bits, and that is 2. 10 is 2. So if I go ahead and compile and run this program, I'll get output of 2 as Z equals 2 after this AND operation. So let's go ahead and run this program. So you can see that Z is 2 indeed. Now the most important question is that what is the benefit of having this bitwise AND operation? The benefit is that using this bitwise AND, we can check if a particular bit is 1 or not. That means if a particular bit of a particular variable is set or unset. Set means it's 1 and unset means it's 0. That we can check using this bitwise AND operator. Let me just explain a little bit more using some examples. Say we have this x as 10, right? So the least significant 8 bits are something like this, and we are interested of checking if this particular bit is 1 or not. Say we don't know how the binary configuration looks like, and we are interested of checking a particular bit. I hope you remember that example of students where the result of students where the teacher wanted to keep all the pass and fail information of 8 students. Now if the teacher is really interested of finding a particular student whether he is passed or failed, then he would very much like to check that particular bit there. So if you are interested of checking this particular bit, then what you can do, you can just do the AND operation with this value by keeping 1 here with another variable. Say I'll initialize y with 4, in that case, 8. In that case, this particular bit, as you can see it here, this is actually 0, 1, 2, 3. That's the third index bit. So it's actually 2 to the power 3, that means it's 8. All the rest of the bits are 0. So if I initialize y with 8, then this particular bit is going to be 1. And if I now AND x with y, and I get this 8 there as result, obviously this is going to be 8 because this bit is 1 and you are having 1 here, so ANDing with this result in 1, and rest of the bits, since we have zeros here for all the other bits of y, so rest of the bits, whatever it's there in the x, they will actually turn out to be zeros. So if we get 8 as result, then obviously the third indexed bit is set of x. And if you get 0, now if you have 0 here, then obviously it will turn out as 0. So all the bits are going to be 0 in that case. So the general thing is that if we have AND operation between 2 to the I and x, and that results in 2 to the I, then the ith bit is set. That means that's 1. Otherwise, if it is 0, that implies the ith index bit is 0. So that's how the bitwise AND operation is useful. I will just show you one example, a program that will demonstrate this idea. Okay, here is a program that will demonstrate how the bitwise AND operation is useful for programming. We would like to check if a number is even or odd without using the modulo operator %sign. We already have used that modulo operator for this purpose, but this time we are not going to use that. So what's the idea? The idea is that if the least significant bit of any integer number is 1, then the number is odd. As you can see that if say x is 5, then obviously the least significant 8 bits are going to be something like this. So here you have 1. This particular bit, that's the 0th index bit, is actually the only odd contributor. This particular position is the 0th index position, and this is actually 2 to the 0. That means 1. The weightage of this particular position is 1, and rest of all the 32 bits are having a weightage that is even. So rest of them are even contributor. So we know that if we add an odd number with an even number, the result is always odd. So all these are even contributors. So if you have 1 here, that means you are adding 2 to the 2 with the number. If you are having 1 at this position, you are adding 2 to the 3 with the number. So if you're having 1 this position, that means in the least significant bit, then we are adding 1 with the number. So that's the odd contributor. So if the least significant bit of any number is 1, then the number is obviously odd. And we are going to utilize this logic to find out whether a number is odd or even. So what we'll be doing, we'll be actually ANDing the given number with 1. And if the result is 1, then obviously the least significant bit of that number is 1. So the number is odd. So if x is say 10, so this is the thing that we have in x, and all the rest of the 32 bits are zeros. Now we have 0 here. That means the number 10 is even. So what we'll do, we'll just AND with 1. That means we are keeping 1 at the 0th index, and we are doing the AND operation with this x or the number. Then we are getting 0. So if we get 0, then obviously the number is even. That means the number doesn't contain a 1 in the least significant bit position. So that's the idea. So let's go ahead and do this. So I'll just perform x and 1, and if that results in 1, then obviously the number is odd. Okay, so you need to put this in parenthesis because this binary operator is having the higher precedence than this comparison operator. So if that equals with 1, then the number x, the value x, contains odd number. So %d is odd, and we can just print x there. Otherwise we can just print out it's even. So that's it. Let me go ahead and run this program. Build and run. Okay, so I'm giving 11 and it's odd. I'll just rerun once more, and I'll give 100 this time, and this is even. So that's how we can use the bitwise AND operator in order to check whether a particular bit is 1 or 0. Now I'll give you one more example just after this, where we'll be actually counting the number of set bits in an integer value. So let's go ahead and do that as well, but in the next tutorial. Thank you for watching.